Hi all, welcome back to my channel. My name is Varsha. Today I'm going to cover in this video the C function pointers. So let's get started. So in this presentation, we will uncover the mysteries of C function pointer and learn how they can be leveraged to build more robust and scalable applications. So to use the function pointer, first we need to define the function pointer. And the function pointer, for defining the function pointer, they are going to get defined as a normal variable, and they can be passed around in other functions, and they can be assigned by any other function address, and they can be changed with the function by changing the address of the functions. And these function pointer can be these function pointer can be passed as the argument. So in the functions call, and when we pass them as the argument, so they allow the dynamic behavior here, because what type of function pointer we are calling in this function, accordingly the behavior of that function will get defined. And they create the powerful abstraction, because the sometime user don't know on calling certain interface what kind of behavior it is going to behave. So but this behavior is going to be the base on the use cases, right? So, and implementing the callback functions. To implement the callback function, we need to have the function pointer. And so whenever we call, we pass a pointer of a function, right? I will explain you. I will explain you in detail next slide how to define the function pointer. So if this is the function pointer we are calling in this func, then and when we are invoking this pointer from this function based on certain situations, so this will be called as the callback function. We'll see that in detail in upcoming slides. And what is the behavior between the pointers and the function call? So function pointer enable the behavior that is not possible with the traditional functions call, because traditional functions call are very static. We know by looking at the code, or by during the writing the code, how that function is going to behave, and that function behavior is not going to change at the runtime. But when we want the dynamic behavior, that time we need to use the functions functions as the pointer. So these are the some example. So what is this first thing? First is the function pointer, which can be can point to the function which receive the integer as the input and return one more integer as the output of this function. So this is the pointer declaration for this function. Okay, this is one more the function pointer declaration for the function which receive the two integer argument as the input and return one more integer as the output. And this is one more function pointer. So that is very similar to this function pointer, but it returns the character in return, right? And this is one more function pointer. So what it does, it accepts the two integer as the input argument, but it returns the pointer of type void star, right? So this is the function pointer declaration will be for this type of function, right? And what is this? This is also very similar to this, but it receive the two integer pointer, right? And return the one more void star pointer. So, and this looks very complex one, right? So this is the function pointer. Sorry, here I forgot to include. So this is the function. Here is the star. Just assume here is the star. Okay. And assume here also is the star. These two places I forgot to include. So suppose this is the also function. Func is the function pointer, right? We receive in the argument the integer, and one more function pointer of type which function? Of type this function, right? So this receives the function pointer ptr of that function pointer type and return void, right? And what is this one? This is also a function pointer. Yeah, I believe these both are same. Only thing is that first one returns the void and second one returning the integer, right? So here it in input it accepts the integer first as the first argument, and second argument is again here the function pointer of type this function, which take the input to integer and return one word star, right? So let's go ahead. So what is this, guys? So this is the structure of file operation. Generally, this structure we use when we implement the device driver. So here, all this behavior of the file operation has been implemented using the file functions pointer. So we know, right? Whenever we want to do the operations on the file, either that operation going to be the type of open. So generally, we try to open the file with the open function. Open function, we can do the read, write over it. We can do the lseek operation, ioctl operation. In case of device driver, we will do the memory mapping, right? And when we want to flush the data after reading that device driver, that file, sorry, so we can do the flushing, right? And we can lock also this file. And this is actually, this structure is specifically taken from the structure of the CDAV. So where file operation get assigned there, right? So this is just an example. If someone going to ask you what is the file operations, how operation done in the device dev and how they are going to do, in that case, these type of function pointer can be assigned there. And one more example is there of the callback function. Here in the signal handler function pointer. So here in the signal handler, so this is good example for the callback. And this is good example for the function pointer. So why here callback? Because based on the event of type SIGINT, this interrupt handler will get callback from here. I will show you this in the example. So just a minute, I'll just open my console. Just this is my system. So where 2.c is the one program I have written. So what is this program is about? So here, if you see, I have taken one interrupt. So this is nothing but the integer, which will get enabled when interrupt coming. So yeah, and this is one interrupt handler. So what interrupt handler this will does? This will receive one interrupt with a number, and this is the interrupt handler. This is a function name, and it returns the void, right? When this interrupt has been received, interrupt variable, this interrupt variable will get set here. This is the main function. So this is the function pointer declaration we are doing for this function, okay? For this kind of function. So initially we should assign this to null, so that this is so that we are following the right process here. So always we should assign to null any pointer before using them. Then we'll try to just print this. We are trying to just print the older interrupt handler, because this signal, what this signal will does, this is one API, OS label system call. So what this does, this will return whenever we are registering the new interrupt handler, it will return the pointer to the older interrupt handler, which was handling this SIGINT before till now, before registering this interrupt handler, right? So this is so here in the next here old interrupt handler. So newly whatever was there earlier, So we are going to print that interrupt handler, and then we are going to print here the new interrupt handler address. Okay. So we'll continue until there is no interrupt coming. If whenever interrupts comes, this while loop will get break and signal we are going to call on receiving this SIGINT. Okay. So let's see how this is going to work. So I'm going to combine this one, 2.c, a.out I'll do. Okay. So before setting the old interrupt, it was 0. After setting the old interrupt was 0 because maybe before there was no interrupt handler was registered. But new interrupt handler address is this one. This is nothing but the function address. I'm printing this in decimal. Now I'll press the Control C, that is a SIGINT. So interrupt handler, so Control C has caused the interrupt, and then now interrupt handler has been called here, right? So this is the thing. Now we will try to see one more example where I have defined the signal handler with the type def. So here this is the function pointer for which we have given the name sig handler underscore t using the type def. Now we will see this has made our reading. For reading, it is very easy. Here, see here, by seeing this line, we'll understand what is going on here. So we have defined one object of this type of function pointer and assigning it to null. And we are printing some address here. Then we are, we are registering the interrupt handler, same as previous one, but here see, using by doing the type def, the reading has it has become the more readable. So like this we can do here. Now here also when interrupts comes, older it is going to call the old interrupt handler. If we do this, then what will happen? Let's see. Interrupt handler call for SIGINT says. Okay, sorry. So interrupt handler will get called here with the this one, and once interrupt has been called and called there, after that before coming out of main function, we are restoring the old interrupt handler here. And one more correction which I have told earlier, these values we are not printing in decimal. These are the hexadecimal printing we are doing here. So that's all I had for the demo. Let's switch to our presentation. So now coming to our interrupt presentation slide. So we have seen the same example from the command line utility where I have shown you how to compile and how to how to execute the program. Yeah, so this is the signal handler I have shown you. But my pointer is not coming. Yeah. So here I am. So this is the function for which function pointer we are going to declare. So this is the function pointer. Here star should be there. Then we are assigning it to null. Then when we are doing registering this new signal handler, right? So older one is coming here. So this is the same one. So this is the registration of the signal, or we can say the callback registration. It's also we can say here. Now let's move to another slide. So like in previous example, I have shown you how type def can can be used to enhance the readable of our function pointer declaration. Like if we want to declare, suppose this is a function pointer, okay, for adding two integer, okay. So this is the function pointer. But if we want to give this name, give the name to this function pointer, so what we can do here, type def, right? Then here int, here we can give the name add, right? Int. Here give the star. Now whenever we are doing the add here and we are declaring the object of add, it says like this is also function pointer of type add, of type this, right? So whenever we want to call this function add, how we can do this? Add two integer, suppose 5 or 6. So like this we need to invoke with the result, right? And type def, as I have shown you, right? This is how you can use the type def. Maybe I can create one more video in the detail how we can use the type def. So what is the uses of the function pointer? So function pointer uses in the sorting algorithm, event handling, and the hardware abstraction. So event handling means how we can use here based on the event, right? We can call different functions pointer, or one function pointer, but we can pass the different argument based on the event we have received. And for the sorting algorithm, the function pointer can be used to implement the custom sorting algorithm that can be parameterized and optimized according to the specific use cases. And in hardware abstraction, function pointer can be used to write a device driver in the hardware abstraction layer that can be reused across the different platform and the architecture. So it means the function pointer we can declare, but the write the function based on the different platform and the architecture. So whatever function is called, and the function pointer will be independent of each other, and according to the type of the platform, we can assign the function to the function pointer and call up appropriately, right? And in the memory management, function pointer used for the garbage collection and the reference counting here. So what is the best practice for working with a function pointer? So first of all, we should be using the correct name. So this is always everywhere in the C programming or any programming, for the variable, for the function pointer, for the structure object, or whenever we are creating any data structure or something, that time we should always use the correct name for that. Sorry. So why we should give? So that it is good for the readability, and it remove so that it gives a meaningful name whenever we are going to use that particular thing. And whenever someone writes the code, it is easy for them to write one. But if some other engineer want to read that code, and the name of the object or the variable give very much flexibility while understanding the code. And always, whenever we are playing around the pointers, we should always assign with the null value, right? So if null value, and whenever we are freeing any pointer, that time we should always again assign to the null. And whenever we are invoking or using any pointer, we should always check for the null, so that segmentation fault or the crash can be avoided. And type def use already we have discussed. And document your code. Always we should give the proper commenting, or whether we can create one more readme document or something, so that it will make others to it will be easier others to understand whatever we have written. So what we can conclude with this today's session. So function pointer, what we have seen, function pointers are very dynamic, and they are daunting. They are power tool in any programming, and use them to create more modular, scalable, and extensible code. And this is not the lecture which I have given today. This is very short lecture, but if we want to learn more about it, we should always look into the source code or the free open source available. just to keep exploring and experimenting and learning more and more to become the perfect in this. And yeah, what next in this? So if we are interested in learning the C program, we need to check out other presentation resources on the programming algorithm and the data structures, so that we should be able to understand all these C language C language building block, right? This is building block. Why? Because without function, what is point? First comes the pointer, then function pointer, then pointer to an object. So there are multiple things. And using the pointer, we can create a multiple type of data structures also. Right? So we need to keep on learning this. Thank you all, guys. That's all I had for today. Do let me know in comment section what else you want me to make next. Thank you all. Have a nice and great learning.